So students, I hope you must have drawn the ray diagrams in case of concave mirror. Now let us see what happens if the object is placed at center of curvature. Now students, while drawing ray diagram, I repeat one more time the special instruction, that is the distance between pole and center of curvature is actually double of the distance between pole and focus. Or you can say that the distance between pole and focus is half of the distance between pole and center of curvature. So if you are not measuring it correctly, the diagram will not come accurately. The pencil should be sharpened also, since if you are not having a sharpened pencil, the ray diagram will not be clear. So students, the object first of all is placed at center of curvature. So now what happens further? First ray I'll take a ray parallel to principal axis. Whenever a ray is parallel to principal axis, from where it will get passed after reflection? Yes, it will pass through focus. So remember it always, a ray drawn parallel to principal axis will be passing through first this focal point. And secondly, the second ray I have taken here is a ray which is passing from focus. So see, if a ray is passing through focus, what occurs now? After getting reflection, it will pass parallel to principal axis. So students, now see the two reflected rays. They are meeting at a point, and wherever they are meeting, what is that point? That point is the point where you form an image. So now let us draw the image. The arrow of the image should meet the point of intersection of the two reflected rays. So now if we see the image, is it straight as compared to the object or it is inverted? Very good. The image is inverted. It is opposite. It is not straight. The image has reversed itself. So the image formed is, students, the image formed is inverted. Since it is inverted, the image is said to be real. So the image formed is real. The image form is inverted. And the best characteristic here is, see, the size of the object. If you see the diagram which I have drawn, I have taken the object of height 2 lines of your notebook and see the image. The height of the image is also 2 lines of the same notebook. So what can I conclude from here? The size of the object and size of the image is same. That means the characteristics of image are the image is real, it is inverted, and the size of the image is same as that of the object. Clear? So students, now let us do the second case. The object is placed between pole and the object is placed between focus and center of curvature. So students, the object is lying between center of curvature and focus. Now the first ray is again the same, parallel to principal axis. A ray going parallel to principal axis, after getting reflected, passes through focal point. So the reflected ray is passing through focus. And the other ray which I am taking is a ray already passing from focus. First was incident rays parallel to principal axis, and after reflection it is going from focus. Second case is if the incident ray is passing through focus, what will happen now? The reflected ray will be parallel to principal axis. Wherever the two reflected rays, listen carefully, wherever the two reflected rays intersect each other, there is the point of formation of image. So the arrow of the image is downward. So the image formed is upright or inverted? Is it erect or inverted? It is an inverted image. So if the image is inverted, it is always real image. And if we compare the size of the object with the size of the image, what can you see? See, the size of the object is of 2 lines, which I have taken, and the image is made up of 3 lines then. So the image formed is magnified, or we can say the image is enlarged. So students, what is occurring here in all? In concave mirror, as the object moves closer to the mirror, the size of the image is increasing. So the image is always formed where the two reflected rays are meeting. And what I am telling you, that if in case of a concave mirror, when the object is brought closer, the size of the image is gradually increasing. See, in the first case, when the object was beyond center of curvature, image formed was smaller, diminished. When the object is placed at center of curvature, the size of the image is same as that of object. And then if the object is between center and focus, now what has happened? The object is coming closer. The object earlier was behind center of curvature, then on center of curvature, then between center and focus. Now the image is enlarged. And if it is placed on the focus, the image formed is highly magnified. And if it is brought further more closer between pole and focus, the image formed is enlarged again. So as you are bringing the object closer, the image formed is increasing in its size. So students, I think this ray diagram of concave mirror is clear to you. Now continuing further, today we will also learn about the formation of image in case of a convex mirror, and we will draw a ray diagram in case of a convex mirror. So students, a convex mirror is a mirror which is silvered from its outer end . So a convex mirror is a mirror which is silvered from the inner part and polished from the outer end. And the object has to place in front of the object has to be placed in front of a spherical mirror. So students, here the object is placed in front of the spherical mirror, that is a convex mirror, but its center of curvature as well as focus will lie inside the mirror. Students, since this convex mirror is forming a part of circle, and that circle will be having a center which is C, and half of the radius of curvature will be focus. We have already discussed in the last week that in case of a convex mirror, the focus is lying inside and it is known as virtual focus because it's not real and it is not outside the mirror. So students, here, now first we will be taking an object lying in front of a mirror. We will draw a line parallel to principal axis. A ray parallel to principal axis has to reflect such that it is passing through focus. Now, otherwise the light has to reflect back. But it seems that light is coming from, it is reflected from the focus point. Since whenever the ray is parallel to the principal axis, it gets reflected from the focus point. Similarly, the ray is passing through center of curvature also, such that it will be reflected back in the same direction. So students, the reflected ray, first reflected ray is passing through the focus point. It appears to pass through focus. And the second, what you will do is take the arrowhead of the object and the point of center of curvature. Keep your scale and draw the line joining the 2 points. And put the arrows, one towards the mirror, it is incident ray, and one away from the mirror, that is the reflected ray. So if you see the reflected rays, what is occurring? They are diverging and they are not meeting in front of the mirror. But when you have produced them backward, can you see a point where the two reflected rays are appearing to meet? They are not actually meeting in front of lens, in front of mirror, but when they are produced backward, they are appearing to meet at a point. And that will be the point where image is formed. So since the image is formed behind the mirror, students, what will occur here? The image formed, see, the object is, if standing in an upward direction, image is also in an upward direction. So the image formed is erect, and whenever the image formed is erect, it is known as virtual image. And as we have discussed today also, that virtual image is always to be drawn dotted. So the image formed, I have shown it a little dotted. And students, all the rays behind the mirror is also to be shown dotted. And if we see the size of the image, compare it with the size of the object, the image formed is smaller in size. So the image is having 3 characteristics: virtual, erect, and diminished. All the characteristics can be learned only by looking at the ray diagram. So students, the image formed, which we have discussed in many cases, which we have learned till now, are, in case of a plane mirror, what kind of image is formed? If you see yourself in your looking glass, what kind of image it is? It is a virtual image, that is an erect image, and is of same size as that of object. So in plane mirror, which kind of image it is? Virtual image, and the size of the image is same as that of object. While in case of a convex mirror, the image is again virtual and erect, but the size is not same. It is a smaller size, a diminished image. So students, the size of the image is smaller as compared to the object. And even if you place the object anywhere in a convex mirror, anywhere, the image will be always virtual, erect and diminished. No matter what is the position of object, image will be always virtual, erect and diminished. So it was a case of convex mirror. But what happened in concave mirror? You are not having one particular type here. You can have a real image or you can have virtual image. And the size of the image are also different. Sometimes diminished. You can even form of the image of same size as that of object, and it can also be formed magnified. The image was diminished when the object was placed beyond center of curvature. The image was of same size when the object was placed at center of curvature, but this same size is not virtual image. It is real and inverted image. And then you are having real, inverted and magnified also. And then you are having variety of virtual, erect and magnified also. So a concave mirror is giving you variety here. But in case of a concave mirror, na students, we are not having virtual, erect and diminished. Virtual and erect is always magnified here, while in convex mirror, virtual and erect is always diminished, and in plane mirror, virtual and erect is always of same size as that of object. So I hope everything is clear to you all. And with this, I come to an end of this interactive session. Students, you all are required to go through the entire PDF and also the video related to this topic again, and then practice the ray diagrams by using scale and with proper measurements, and understand all the characteristics of image formed, as it will be further used in your numerical part also. So thank you, students.